Hello. So I'm presenting here for you as just a sort of review, recap as we move into a new unit talking about stream flow. I want to just talk about a cross section of a watershed and just remind ourselves what happens when a storm comes through. The storm comes through, drops rain on this watershed. What happens to that water? Where does it go? So I'll start over here on the left-hand side of the watershed. And we know that the trees and the vegetation are going to trap some of that water. And what happens to that water? We know that we lose some to the atmosphere, right? So that is our evaporation. The water is lost back to the atmosphere. And that can be a short time frame or a longer time frame. And we just covered that then we lose some of that water down into the ground. And that water loss down into the ground is our infiltration. And it will continue to seep into the water until it reaches what we call our water table and becomes groundwater. There's also this very shallow layer underneath the ground that we need to account for. And in this layer, some water does get trapped and will begin to flow just under the surface towards the river. And we call that flow subsurface flow. Of course, if puddles become big enough, they will run off on the surface of the water, and if that subsurface flow is saturated, they will run over the hill and become what is called surface flow or surface runoff. That subsurface flow and that surface runoff is going to enter the depression of the watershed, often in a stream or lake, and become our runoff or our stream flow. Interestingly enough, I've added some more red arrows here to show that even when water enters into the groundwater table, and you can learn more about this if you take Mauer's groundwater class next quarter, it does eventually intersect with the stream flow and become part of the stream flow. Okay, so I'm actually going to define for you two different types of runoff. So the two types of runoff are direct runoff and then just runoff. Direct runoff is what we were looking at previously. And direct runoff is equal to, got my equal sign here, precipitation minus infiltration. It's all the water that comes into the watershed minus on a short time frame what is lost to underground flow. Runoff, on the other hand, is equal to stream flow. Okay, and that is also equal to surface runoff plus the subsurface runoff. Okay, so stream flow or runoff is equal to the subsurface runoff plus what runs in the surface. Okay, great. But what exactly is runoff? There are lots of ways to define runoff. One of the ways that I really like to define runoff, helps me really think about it, is runoff is water on the run. Okay, so it's on the run or it's in a flowing state. So what is runoff? It is water on the run. So there's two kinds of runoff. There's surface runoff, and surface runoff is the part of the runoff that travels over the surface of the watershed to reach the stream. So it never is underground. And then some subsurface runoff is runoff that travels under the surface to reach the stream. And so as a reminder, runoff is analogous with stream flow. So let's take a look at what we call a streamflow hydrograph. As the name implies, streamflow hydrograph is a graph. The graph has time on the x-axis and flow on the y-axis. And so what this figure shows is how the flow in the stream changes over time. And these hydrographs follow similar patterns and have particular features that we want to pay close attention to. So for example, we always want to know what the peak flow is. This is really important when we're designing anything around bodies of water. We want to know for any given storm how high of flow we expect in any particular part of the river or stream, and therefore how physically high that is going to rise in the river. Similarly, we want to know the time to peak, the T sub P, how long it's going to take to reach that peak flow. We have two parts of the hydrograph. On the left-hand side at the slower times, we have the rising limb, and that's how fast the water will come up from what we call the base flow, I'll label that in a minute, up to the peak. And then on the other side, as the flow goes down, we have the falling limb. If you live near any rivers or streams, you may notice that there's always a little bit of flow in the river or stream, regardless of the time of year or if there's recently been a storm event, and we call that the base flow. And we're going to work on different ways to determine the base flow as we move forward this quarter. This hydrograph I drew is perfect, right? But I'm going to show a hydrograph from the Guadalupe River at 101. So this is not far from campus. And this hydrograph was not from that long ago. This was about a month ago, so April 3rd through April 8th, 2020. And a few things to notice here. First of all, notice that the y-axis here is actually in feet. So in every river, the stage, we call it stage, and you'll read about this more in the assigned readings, and the flow are directly correlated, right? So for the most part, we know based on the geometry of a river that if we know the stage or how high the water is, that we can figure out the flow if we also know the velocity. But there's a direct correlation there. So this is shown in stage. But you'll see that in reality, what happens is it's not this beautiful, perfect curve, but we had our base flow coming in at the beginning of April, and then it began to rain, right? So here we are, it started to rain, and then the rain leveled off and maybe it stopped, but then another storm came in, so the river rose, and that continued throughout the day on April 5th till we got to our peak, and then we started to fall, our river fell, and then it rained again, right? So we got this additional peak on April 6th. Okay, and if you look at bigger rivers, you'll see this even differently. So that is an introduction to hydrographs, and hopefully that helps to add to what you read about, and you can be successful on our short quiz.